Hello dear friends, Assalamu alaikum. Welcome to CPSCS online class again and my channel Chemistry School. This is Shafik with you. Dear learners, today in this video I want to share with you some information regarding the arrangement of the electron in different orbitals. We have some rules to arrange the electron in different orbitals, different energy levels or different sub-energy levels by some rules. There are main three rules we have. Look at here in the whiteboard, dear learners. Aufbau principle, Hund's rule, and the Pauli's exclusion principle, dear learners. By this, we can easily arrange the electron in different energy level, different orbitals also. The first of all, we want to discuss about the Aufbau principle, dear learners. The Aufbau is a scientist. Aufbau? No, this is a term. This is a word from German word. This is Aufbau. Aufbau is German word. The meaning of this word is building up. Building up. I mean, when you want to grow up a building, then you should found it first, then first floor, second floor, third floor, like that. And if you just increasing this is the increasing way to find out this. And dear learners, this is the building up process. What is the main concept regarding the Aufbau principle? Main concept is, dear learners, electrons are occupying different orbitals according to the increasing energy. I mean, if we want to say this in easy way, electron enter first to the lower energies orbital, then according to the higher energies orbital. I mean, electron first enter to the that orbital which is having lower energy. And how can we find out which orbital is lower energies, which orbital is higher energies? So electron enter first, lower energies. Electron, dear learners, electron enter first, first to the orbital who is having lower energy, dear learners, so is having lower energy, and gradually this will gradually in the higher energies orbital, higher energies orbital. Okay. And how can we understand that the energy? How can we find out the energy, difference of energy? Dear learners, there is a rule here. The rule is N plus L rule. N plus L rule. Already we know about the N and L. N means the principal quantum number, the energy level, and L means the subsidiary quantum number. I mean, this is the energy level. Okay, energy level, and L is the sub energy level. No problem here. And we can easily now find out the energy of the orbitals. Look at this. If I want to find out the energy, the 3D and 4s, who is having the lower energy, then we can easily find out this. Dear learners, look at this. Here 3D means the value of N is 3D here, and the D means the subsidiary quantum number, L is here 2. This is the sub cell. L, when L is 2, then it will be the D. If L is 0, S, L 1, then it will be P. In the previous lecture, I just talked about ins and out about regarding this in quantum number. Okay, see there. And here, look at this. The value of N is 4 and value of L is 0 for S. Okay. And if we just add this, N plus L means 3 plus 2, I mean here 5, and N plus L means 4 plus 0, I mean here 4. Look at this. who is having lower energy, dear learners? The values of n plus L where lower, then it will be the lower energies. So 4s is lower energies and 3d is higher energies. So electron enter first to the 4s orbital first, then third 3d, and that is why the 19th electron of potassium enter to the 4s orbital instead of 3d. Dear learners, look at this. 3d is in the third energy level. If we configure the draw the simple atomic structure, look at this. This is the first energy level. Here 1s orbital will present. In the second 2s 2p orbital is present. In the third 3s 3p and 3d orbital are present. And in the fourth energy level 4s 4p 4d and 4f and orbitals are present. According to the energies of energy level, look at this. 3d is the first, then 4s. So the regular principle shows that electron should enter first to the 3d, because of 3d is in third energy level and 4 is in the fourth energy level, I mean next energy level. But mind it, electron enter to the orbital according to their energy of orbital, not according to the energy of energy level. This is the Aufbau principle, dear learners. According to this, we can arrange 100 elements electronic configuration from Aufbau principle. And here I have a tricks and crazy tricks about the electronic configuration in Bangla version. In that videos you can easily find out you can easily configure any type of element from 118 elements. I mean, you can just configure the electronic arrangement within 5 seconds from 118 elements, dear learners. Just keep watching that videos. This is according to this rule. What is the arranging order of the orbital? Look at this here. SS, PS, PS, then DPS, DPS, FDPS, and finally FDPS. Okay, FDPS. And if we just numbering the S first from 1, this is 1, 2, 3, 4, 5, 6, 7, this is 8. And now we just numbering the p orbital from 2, and this is the p orbital. This is from 2, this p3, this p4, this p5, this p6, and this p7. Now d orbital we want to start from 3d, 4d, 5d, and this is 6d. And for f orbital we want to start by 4f and 5f, like this. This is the arrangement of the orbitals. Look at this. 1s, 2s, then 2p, 3s, 3p, 4s, then 3d, 4p, 5s, 4d, 5p, 6s, then 4f, like this. By this we can easily arrange different types of electronic configuration of from 118 elements. That's all about the Aufbau principle, dear learners. Now let's go to know about the Hund's rule, dear learners. Dear learners, this is Hund's rule. Already we have done Aufbau principle here. Now Hund's rule. What is Hund's rule? This also another rule for electronic configuration. Hund's rule means the electrons are distributed in different degenerate orbitals at maximum ampere state. I mean, when the electron just enter in the different degenerate orbital, then the electron just enter with the maximum ampere state. And what is degenerate orbital? Dear learners, degenerate means, look at this, degenerate orbital. Degenerate orbital means the orbitals which having the same energy. Look at this. P orbital having three P orbital px, py, and pz. D orbital like this, 5 orbital dxy, dyz, dzx, dx square, y square, and dz square. This is the 5d orbital. And we know that each and every orbital contain electron, maximum 2 electron. Here, this is the 5 orbital for d sub energy level, 3 orbital for p sub energy level. When electron enter in this orbital, then electron enter first in maximum unpaired state to that orbital. These orbitals px, py, pz having the same energies, and these are the degenerate orbital. And when the energies will differ from px to py, then it will be the non-degenerate. But at this state, this is degenerate state. This is the main concept regarding the Hund's rule. I mean, electron enter the degenerate orbital with maximum unpaired state. Look at this. With an example, we can easily clear it. For nitrogen, if we configure this 1s2, 2s2, and 2p3, okay, nitrogen 7. But we want to configure this electron configuration like this: 2s2, 2px, 2py, and 2pz. And you can arrange this electronic configuration here to 1 like this. And you can also configure these 1s2, 2s2, 2px1, 2py1, and 2pz1. And here this is 0. And which one will be correct? Which one will be applicable for Hund's rule? Here, look at this. How many electrons are present in the p orbitals? 3. And p orbitals having 3 orbital which having same energies px, py, and pz. We write down here, split out here, and then we enter the electron like that. But this is not correct according to the Hund's rule. This is the correct, because of, look at this, the 3 electrons just enter these 3 orbital in maximum unpaired state, 1, 1, 1. And that is why this is the these rules also. Another name is box method. Look at this here. We can easily write down the box method of electronic configuration like this. This is the 1s orbital. How many electron here? 2 electron. 2s, how many electron? 2 electron. And this is 2px, 2py, and 2pz. How many orbital here? Electron here? 1, 1, 1. Among their spin will in same direction. Look at this. These are the spin. Indicates the spin, dear learners. Okay, and there is information here. For s orbital, the Hund's rule is not applicable. Because of s having 1 orbital, there is no degenerate orbital for s. So this is s. For s orbital, there is no chance to apply the Hund's rule. Another here, for neon elements, neon will follow the Hund's rule or not, dear learners? Look at this. What is the electronic configuration of neon? 1s2, 2s2, 2p, 6. I mean 10. And here, each and every p orbital will fill up the electron. And there is no maximum unpaired state here. Then that is why the neon also doesn't applicable for the Hund's rule. Which elements having partially electron in their degenerate orbital, then the electron enter there with maximum unpaired state. Look at this here, partially filled. But this p orbital having 3 degenerate orbital, px, py, pz, and then the electron enter maximum unpaired state. But if there is 6 electron, there is no chance to fill up with unpaired state, and that is why neon doesn't follow the Hund's rule. Okay, dear learners, finally we want to learn about the Pauli's exclusion principle. Dear learners, now we want to learn about the Pauli's exclusion principle. Already we have done here Aufbau principle, Hund's rule regarding the electronic configuration. Now this is Pauli's exclusion principle. What is Pauli's exclusion principle? Here, for two electron of an atom, the four quantum numbers cannot be identical. I mean, at least one quantum number will be different. This is the Pauli's exclusion principle. I mean, if we find out the four quantum number for two electron, then we can see that one quantum numbers will be differ from another quantum number. This is the Pauli's exclusion principle. Dear learners, for an example here, for helium, the electronic configuration is 1s2. Now, if we just want to find out the four quantum number for two electron of helium, then we can get easily the Pauli's exclusion principle. Look at here, learners. For the first electron, of helium, this is 1s1. So what will be the four quantum number, dear learners? This is this one indicates the main principal number. I mean the energy level. This is the value of n indicates the energy level. N is here 1. This is the principal quantum number. Then S indicates the sub energy level. When L is 0, then it will be the sub energy level S. I mean, in quantum numbers video, you can get different types of information regarding this. See there. And as L is equal 0, M will be 0. Okay, dear learners. And now finally the spin quantum number will plus half. Why I write down here plus half? Because of this orbital contain just one electron, and the spin quantum number expresses the electron number, plus half and minus half. Each and every orbital can can exist maximum 2 electron if the spin quantum number are different here, opposite. And for the second electron, dear learners, I mean 1s1. Now this is for second electron. We can write down here n is 1 also, and as S is here present, so L will be 0, and as L 0, then M will be 0, and S finally minus half. Because of this is the second electron. For the second electron, the S will be the minus half. If you write down the for the first electron, S is minus half, then it will be plus half, as you like. The electron in orbital, this orbital having maximum capacity to exist 2 electron. One electron just rotate in its own axis clockwise, and another electron anti-clockwise. And that is why if you write down for the first electron plus half, then the second electron minus half. If you write down first electron minus half, then it will be second electron minus plus half. Look at this here, learners. For the first 3 quantum numbers, n, l, m, the same values for 2 electron, but finally in the fourth quantum number will differ. Look at this here. For first electron plus half and second electron minus half. This is the Pauli's exclusion principles explanation. And finally, we have got alternative form of Pauli's exclusion principle. What will be that? This is that each and every orbital can contain maximum 2 electrons if their spin are opposite. Look at this here, dear learners. This is the Pauli's exclusion principle, and that's all today. Thank you for watching my videos. Keep watching and get more information from my different videos regarding your chemistries, different topics. Thank you. Allah Hafiz.